We will see one more example, that is when zinc reacts with hydrochloric acid, it forms zinc chloride and liberates hydrogen gas. So, this is the first step, that is writing the chemical equation, that is which is in a skeleton form. In second step, we will write the number of atoms on both the sides. We will write one table. Atoms left hand side and right hand side and result. Atoms left hand side, right hand side and result. This is before balancing and this is after balancing. We will check after balancing. The atoms are zinc, hydrogen and chlorine. Zinc, hydrogen and chlorine. So, in this first we will check the number of zinc atoms. The number of zinc atoms on reactant side are 1 and the number of atoms on product side are also 1. So, it is equal. Next, coming to hydrogen, the number of atoms on left hand side are 1 and here on right hand side or product side are 2. So, it is not equal. So, the number of hydrogen atoms are not equal. Next, coming to chlorine, the number of atoms on reactant side are 1 and the number of atoms on product side are 2. So, it is also not equal. So, we have to balance hydrogen and chlorine. So, these two we have to balance. So, now we will write after balancing hydrogen we will write the equation. So, zinc plus hydrochloric acid gives rise to zinc chloride plus hydrogen, zinc chloride plus hydrogen. So, here what we have to balance? Hydrogen. Here on left hand side 1 and right hand side 2. So, we have to balance hydrogen by placing 2 here on reactant side. So, that the equation will be like this. The number of hydrogen atoms will be equal. When zinc reacts with 2 moles of hydrochloric acid, it forms zinc chloride plus hydrogen. Here 2 hydrogen, here also 2 hydrogen. Next step, we have to balance chlorine. So, here on left hand side the number of chlorine atoms are 1, on right hand side the number of chlorine atoms are 2. So, we have to increase the number or we have to change on left hand side. After balancing, the equation will be like this: 2HCl plus ZnCl2 plus H2. So, here the number of chlorine atoms will be 2, here also the number of chlorine atoms are 2. So, that the chlorine also become equal. Now, we will check whether the complete atoms which are present in this equation are equal or not. So, first we will see zinc. Zinc on left hand side are 1, on right hand side also 1. So, it is equal. Next, hydrogens on left hand side 2, hydrogens on right hand side 2 equal. Next, chlorine it has 2 is for both hydrogen and chlorine. So, chlorine has 2 atoms on reactant side and 2 on product side. So, they are also equal. So, the number of atoms of zinc, hydrogen and chlorine both all are equal. So, that the equation is balanced. The equation is balanced. We can whether it is in smallest coefficient or not, we will see. it is already in smallest coefficient, so no need to change the equation. So the balanced equation will be like this: zinc plus HCl, 2 HCl gives rise to ZnCl2 plus H2. This is the balanced equation. Clear? We will see one more example in which iron oxide reacts with aluminium. It forms iron and aluminium trioxide. First, this is the first step. In second step, we will see the number of atoms on left hand side, that is reactant side, and the number of atoms on right hand side, that is product side. We will write one tabular column. Atoms, left hand side, right hand side, and the result. This is after balancing, we to check. It contains iron, aluminium, and oxygen. These three are the atoms present in this equation. Now first we will check with iron. So the number of iron atoms on left hand side are 2 and right hand side are 1. It means it is not equal. So we have to balance iron. In next one, aluminium. We will take aluminium. The number of atoms on left hand side are 1 and right hand side are 2. So it is also not equal. We have to balance aluminium also. Next, oxygen. So the number of oxygen atoms on left hand side are 3. The number of atoms on right hand side are also 3. It is equal. This is before balancing. Now, first we will balance iron first. So here I am writing equation: Fe2O3 plus aluminium gives rise to Fe plus Al2O3, aluminium trioxide. So we have to balance iron, that is 2 here, we have to place 2 here at coefficient place. If we place 2, the number of iron atoms become equal. So iron on left hand side are 2, on right hand side also 2, it is equal. Next, in second one we have to balance aluminium. So here aluminiums are only 1, here 2. So if we place 2 here on reactant side, it becomes equal, 2 aluminiums and 2 aluminiums on right hand side. Now the equation become Fe2O3 plus 2Al gives rise to 2Fe plus Al2O3. Now we will see oxygen. So the number of oxygen atoms on both sides, we will see after this reaction: 3 on left hand side, 3 on right hand side. So there is no need to change the number of atoms of oxygen. So Fe2O3 plus 2Al gives rise to 2Fe plus Al2O3, aluminium trioxide. So this is the balanced equation. This is the balanced equation. Here we will check. Iron is already balanced with 2 on left hand side and 2 on right hand side. Coming to aluminium, aluminium on left hand side are 2 and right hand side also 2, it is also equal. Coming to oxygen, oxygens on left hand side are 3 and right hand side also 3, it is also equal. So like this, this is the balanced equation. And we have to check whether the equation is in smallest coefficient or not. It is already small in the smallest coefficient, so no need to change the equation. So like this we can write or we can balance any chemical equation by using these 4 steps. One more example, that is when propane reacts with oxygen, it forms carbon dioxide and water. We will see how to balance this equation by using 4 steps which we already learned in the previous class. In first step, we have written the skeleton equation of the reaction, that is when propane reacts with oxygen it forms carbon dioxide and water. Coming to second step, we will see how many number of atoms of each compound are present on left hand side and right hand side, that is reactant side and product side. We will see it by using one table. So, the atoms present on left hand side and the number of atoms present on right hand side we have to check. Carbon, hydrogen and oxygen. These three are the atoms present in this equation. And we will write one more column, that is result, so that we can understand which atom we have to balance. So, first take carbon. The number of carbon atoms on left hand side or reactant side are 3. The number of atoms on right hand side or product side are 1. So, the result is it is not equal. The number of carbon atoms are not equal. Next, coming to hydrogens. The number of atoms on reactant side are 8. The number of atoms of hydrogen on product side are 2. So, here the hydrogen atoms also not equal. Next, coming to oxygen. Here on left hand side the number of oxygens are 2. On right hand side, that is product side, the number of oxygens are 2 oxygens here, 1 oxygen here, total 3. So, it is also not equal. Okay. So, if we see these 3 atoms which are present in this equation are not balanced. So, what we have to do? We have to balance the number of atoms of each molecule. So, we will see. First, we will start with carbon. We will start with the carbon. So, we have to balance these 3. After balancing, we have to write a tick mark against each atom. So, first we will take carbon. So, the number of atoms on left hand side are 3. Now, we will see, we have to, if we balance carbon, now the equation becomes C3H8 plus O2 gives rise to 3 CO2 plus H2O. So, now the carbon atoms are balanced. So, 3 here, 3 here. So, the carbon atoms are balanced. Now, in the next step, we have to balance hydrogen. So, the number of hydrogens on left hand side are 8. Here, the number of hydrogens on right hand side are 2. So, here what we have to write? We have to write 4 here, so that the number of hydrogen atoms will be equal. So, by balancing hydrogen, the equation will be like this: C3H8 plus O2 gives rise to 3 CO2 plus 4 H2O. So, that the number of hydrogen atoms 4 into 2 equal to 8. So, the number of hydrogen atoms on left hand side and right hand side become equal. Next, now balancing oxygen. So, the number of oxygens on left hand side are 2 and the number of oxygens on right hand side 3 2s are 6, 4, 6 plus 4 total 10. So, here we have to balance the oxygens on left hand side, that is reactant side. So, after balancing, the number of oxygens will be C3H8 to become 10 which are on the product side or right hand side. We have to place 5 here, so that the number of oxygens will be 10. So, if we place 5 O2, the equation will become like this: 3 CO2 plus 4 H2O. Now, the oxygens also become equal. So, in first step we balanced carbon atoms by placing 3 here, and after hydrogens, if we take hydrogens, the number of hydrogens on left hand side are 8. To balance this, we added 4 here. In first step we added 3, in second step we added 4 to hydrogen, so that the hydrogens will be equal. After the next step, the oxygens are balanced. To balance oxygens, we placed 5 here, because 3 into 2, 6 plus 4, total 10 oxygens are present on product side. So we placed 5 on reactant side, so that the number of oxygens also become equal. So after these 3, again we can check one more time. So the number of carbon atoms on after balancing, here 3, here also 3, the number of carbon atoms 3 here, and we will take one more table so that we can understand. So atoms are carbon, hydrogen and oxygen. So the number of left hand side and right hand side, and result, the number of carbon atoms on left hand side are 3 based on this equation 3, and the number of carbon atoms on right hand side also 3. So the result is equal. And next, hydrogens on left hand side 8, on right hand side also 8, the result is equal. And coming to oxygen, 5 into 2 10 oxygens on left hand side, 3 2s are 6 plus 4, total 10 oxygens on the right hand side, so that the equation will be equal. The third step, we have to see whether the equation is in smallest coefficient ratio. It is already in smallest coefficient ratio, so no need to change this equation. So we can directly write the equation as it is. C3H8 plus 5O2 gives rise to 3CO2 plus 4H2O. And in the fourth step, we will check the number of atoms that we already did here. Okay, na? So these are the 4 steps to balance the chemical equation, that is propane reacts with oxygen and forms carbon dioxide and water. So this is a balanced chemical equation of this reaction.